Hi, my name is Bhagwan Nayak Megawat, and I'm presenting today wildfire detection using satellite images with efficient net V2S. So the main goal behind this is like wildfire are becoming more frequent due to the climate change and human negligence and the deforestation. Early detection is crucial, but due to manual traditional methods like ground sensors and manual monitoring are slow and not stable. So I set to build a machine learning model that could automatically detect the wildfire scenes from satellite images. This model is fast with more accuracy and minimal complexity. So for building this model, I have used a public data set from the Kaggle, which is named as like wildfire detection image data, and the data has two folders like fire and no fire, and it has the 80 is to 20 ratio of the testing and training validation data. So images are resized to 224 into 224 for model input, and the observations and hypotheses are like the complex model struggled in real time interface, but this model is very good. The lightweight models generate better with transfer learning. This being a lightweight model, efficient net V2S can detect fire accurately with low interference time. And here I have done few literature review, and I have studied with other papers, and the most of them are used like YOLO, UNET, large, and these need high compute power, so it takes a lot of time. So few of them explored lightweights like CNN for fire detection, but it is also proven as time taking. So there is less work done on efficient net V2S, and it's rarely used even though it's a lightweight but highly efficient. So this work fills the gap with classification only, the fast development focus. And next, the methodology like processing, uh, it follows like resizing the data, normalizes and arguments, and later efficient net V2S. The images are fine tuned and then trained with the Adam W plus cross entropy loss, and in the end it was validated on testing data on unseen data and seen data. The results, the validation accuracy, it's shown 97.54 when I tested, and testing accuracy was 92.65. So F1 score and fire no fire were very high. So let me take you to the Kaggle notebook and show you the real time demonstration of the project I have done. So initially, I have taken TIM library. So it has a efficient net V2S. I used PyTorch for this building. So at initial stage, I just loaded the Kaggle dataset. We can see the dataset here. Like testing, it has fire and no fire with images. So it's a public dataset. And initially, I loaded the dataset, and it shown the path exists and true forest fire, and dataset has 1900 images. Um, Next, I have classified the images to fire and no fire, which is like fire images are 928 and no fire images are like 901, which is like 80 to 20% ratio. It's good for the testing and training. And as we go down, I initialized this model. Later, I trained it for 20 epochs. For each epoch means the model takes one round, like the model sees once the whole images in the data set. So I have trained it for 20 times, so it's like good, and it's not over trained, so and it's not less trained also. So the training accuracy is low initially, the validation accuracy also, see it's 93.72, but as we go down for the each epoch, the validation accuracy is increasing, and every time it stores the best validation accuracy. So as we can see in the seventh epoch, it's around 98.09, and it's stored as the best, and later there is no best validation accuracy. So as we see, I have plotted this validation accuracy and training and validation accuracy. It's like training was around the 84 to initially it was 84, and now it's gone to 98.06, and validation was from 94 to it's 98. uh, there are less training losses in this model. It's from 0.35 milliseconds to it reduced to nearly 0 seconds, like 0.001. So to after training this model, I have tested it on the images from my own data set, which I have trained on, and I'll speak about it later. And here is the confusion matrix of my data set. It's like predicted actual and fire and no fire. So the prediction was matches the actual one. Here we can see the precision, recall, and F1 score. And F1 score is the average of the precision and recall. As more the F1 value, the better the model performs. So you can see for fire it's 0.08, for no fire it's 0.98. So confusion matrix, it predicted like for actual fire, it predicted fire as 21 out of 22, and one as no fire. And for no fire, out of 46, it predicted 3 as fire, and 43 as no fire. So it gives high efficiency. And I have trained this on, so I tested this on the own data which I have trained, and it gave high accuracy. It gave output with high accuracy. It predicted, and it was actual fire, no fire, and showed no fire. Here you can see. Here is also no fire, no fire. Then here is the fire, and it is also shown fire. So it works good on the scene data, train data. So I just wanted to test it on the real time data, unseen data. So now I need to take a image from the Google, and we'll go with this. So now I'm gonna upload that image. So we just loaded the data set and we're going to copy the path. See, it has predicted a fire with a 100% confidence accuracy. So this model works for both trained and untrained data, seen and unseen data, which has taken from the Google. So this shows that this model has been trained very well. So I have generated confidence matrix, confusion matrix for this also. See, it predicted like fire, and it predicted good. And in earlier I have like shown you with the six pictures, like with three fire and three no fire in the previous demonstration. You can see. So in the present, in the discussion, like my research questions, it shows like efficient net V2S balances speed and accuracy. It's like very fast and more accurate. It allows transfer learning and rapid convergence. Misclassifications like mostly smoky or noisy images, it has less that thing, and real time capability suitable for drone and surveillance. It's well installed in the drone system. And as you have seen me, the code and interference new image, the model outputs the class label fire and no fire plus confidence visualization input image plus predicted label shown in the output. So I can conclude this topic with like lightweight accurate model built under a day, and stronger generalization and fast deployment ready. It can be used, can assist firefighter systems with real-time alerts. Thank you.